A monk sits perfectly still. Wires trail from his shaved scalp. Inside a lab in Wisconsin, machines record something no one expected. His gamma waves are the highest ever recorded in a healthy human. He is not sleeping. He is not praying. He is watching his own mind. So what actually happens inside a meditating brain? For centuries, we called it mysticism. Then scientists put it in a scanner. What they found changed how we think about the adult brain forever. It turns out sitting still can physically reshape the tissue between your ears. This is the science of the meditating mind. For most of history, meditation belonged to temples, not laboratories. Western science ignored it, calling it too subjective to measure. Then, in the 1970s, one cardiologist decided to test a quiet claim. Herbert Benson, a Harvard cardiologist, brought meditation into the laboratory. Benson invited practitioners of transcendental meditation into his Harvard lab. As they meditated, their heart rate slowed and oxygen use dropped sharply. He named it the relaxation response, the opposite of fight or flight. Oxygen consumption fell by up to 17% in minutes. For the first time, a mental practice showed clear physical signatures. But relaxation was only the surface. Decades later, brain imaging let scientists look far deeper. Sara Lazar, a neuroscientist, discovered meditation could physically thicken the cortex. Lazar started meditating for a running injury and noticed she felt calmer. Curious, she scanned the brains of long-term meditators against non-meditators. Her 2005 study found their cortex was measurably thicker in key regions. Thicker in the prefrontal cortex, tied to attention and decision-making. Some meditators in their 50s had cortex like 25-year-olds. The brain, long thought fixed in adulthood, was clearly still changing. The mind can change the structure of the brain. But was meditation causing the change or attracting certain people? To answer that, Lazar ran a controlled 8-week experiment. Complete beginners practiced mindfulness for about 30 minutes a day. After only 8 weeks, their brain scans had visibly shifted. Gray matter grew denser in the hippocampus, vital for memory and learning. 8 weeks was enough to see structural change in adults. And one region actually shrank, the amygdala, the brain's fear alarm. Less gray matter there tracked, with lower reported stress levels. Meanwhile, another scientist chased the extreme end. Richard Davidson founded a center to study the brains of elite meditators. Davidson wired up Tibetan monks with over 10,000 hours of practice. He wanted to know what a lifetime of training does to the brain. Their gamma wave activity was the most intense ever documented. Gamma waves link distant brain regions during moments of insight. In the monks, this state was not a flash, it was steady. These are the Olympic athletes of mental training. But you do not need a monastery to move the needle. Studies point to the default mode network as a key target. That network hums when your mind wanders and chatters to itself. Overactivity there is linked to rumination, anxiety, and unhappiness. Studies suggest people spend nearly half their waking hours mind-wandering. Meditation appears to quiet this restless, self-referential chatter. Experienced meditators show less default mode activity on scans. The result is a brain less trapped in loops of worry. But here is what the hype gets wrong about meditation. It is not a magic pill, and it is not risk-free for everyone. For some people, intense meditation can surface anxiety or distressing memories. Consult a mental health professional if this occurs. The real lesson is subtler than any headline about brain size. Your brain is not a fixed machine. It is constantly remodeling. Attention is a muscle, and where you place it slowly sculpts you. Some research suggests even 10 minutes a day may show measurable benefits over weeks. You are not clearing your mind. You are learning to watch it. Each time your mind wanders and you return, that is the rep. Next time you sit and breathe, remember, You are physically training tissue. The stillest thing you do may be the most active.